Triangle Inequality theorem, and this is for in one triangle, which says that the lengths of any two sides have to be greater than the length of the third. So if I add, say, PQ and QR, it has to be greater than PR. So blue plus red greater than green. Likewise, if I take PQ and I add it to PR, it has to be greater than QR.
I don't think it'll ever be less.
And finally, if I add PR and QR, it has to be greater than PQ. Can't be equal, has to be greater. And if you think about it, it makes sense, because if I took this triangle and I broke it right here and I laid those two sides down flat, they would overlap, wouldn't they? So if I put them together, so I'd move them out so that they'd line up, then it would be longer than the PR. And the same thing is with the blue, the PQ, and the PR. If I did the same thing, if I broke this here and I pulled it out that way and laid it flat, it's going to be longer. So this is one of those things I was saying that it sort of makes sense. It's just by looking at the picture of a triangle, you can say, oh yeah, that has to be that way. So to tell if two things if they give you three lengths and they ask you, can this be a triangle? I add 8 plus 15, is that greater than 17? Yeah. If I add 8 plus 17, is that greater than 15? Yeah. Yep. If I add 15 and 17, is that greater than 8? Mm-hmm. Yes. So these three things are still true. All pairs of sides add up and make greater than the third side. So yeah, it could be a triangle. When I try here, if I go 6 plus 8, is that greater than 14? It's equal.
So
it can't be equal. It has to be greater, so no, this one can't be a triangle. So you just take the pairs and just try each combination of two and make sure it's greater than the third one. If it's not, if it's less than or if it's equal to, it can't be a triangle. This is not the Pythagorean theorem because this is not a right triangle, right? So I cannot decide, I can't figure out what exactly this length is, because it can have a lot of different lengths because it depends on the angles. And the only way I could figure out the exact length of this side is if I knew this angle and I did some trig.
Yeah, I hate this.
We're not doing that. But we can determine what are the possible ranges. Okay, if I call this x, I know that 7 plus 3 is going to have to be bigger than that. Oops, 8. Bigger than x. Well, I also know that x plus 7 will have to be bigger than 3, and x plus 3 would have to be bigger than 7. And so I can solve each of these.
It could be 5, 4.
So I get 10 is greater than x, or you could say x is less than 10, however you wanted to write that. If I subtract 7 from both sides, I get x is greater than -4. And if I subtract 3 from both sides, I get x is greater than 4. Well, we're not going to use the -4 because if I plug in, say, 0, 0 plus 3 is not greater than 7.
So
it has to be at least positive 4. So it's going to be 4 is less than x is less than 10. So it's going to have to, x is going to have to be somewhere between 4 and 10. I'll just call this y. So 8 and 13 is going to have to be greater than y. 8 and y is going to have to be greater than 13, and 13 and y would have to be greater than 8. If I add these together, I get 21. If I subtract 8 from both sides here, I'm going to get 5. If I subtract 13, I'm going to get negative 5. But again, if I plug in any number between negative 5 and positive 5, so let's say I pick 3, it won't work anymore.
It couldn't work
It's-
because you can't be a negative distance.
Well, no, but even if I picked a positive that's greater than negative 5, if I pick something like 3, y has to be greater than 5,
Yeah, I know,
or it won't
but I'm
work.
just saying,
So,
you can't have a negative distance.
no, you can't. I am? Okay. If two sides of a triangle are congruent to two sides of another triangle, so what I have is this side maybe is congruent to this side, and this side is congruent to this side. Okay, and I'm going to go ahead and label these triangles just so we can give them some comparison letters. Okay, so two sides of this triangle are congruent to two sides of that triangle. If the included angle is the angle that comes between the two sides of the first triangle is larger than the included angle of the second triangle. So I'm just going to give them random numbers. Say if this one's 45 degrees, maybe this one is 30. 45 larger than 30. Then that tells me that this third side, that's this side right here, those are the third sides. Let me just make that a different color. This one will be bigger than this one. So the fact that angle, wrong pen, the fact that angle B is greater than angle G means that AC is going to be greater than FH. Because the other two sides are congruent, right? So AB, here I'll write it down. AB is congruent to FG. That's AB here and FG here. And then BC is congruent to GH. So these two are the same length, but the angle is different. So it's kind of like, you know, okay, so basically we had the hinge theorem, which said if the two legs were the same size and one angle was bigger, that meant the third side was bigger. Well, the backwards of that is that if we have, so converse is the reverse. So if we have two sides that are congruent, and then the third sides, let's say one is 15 and one is 10. So I have AB is congruent to GH and BC is congruent to HI. Well, then if the third side is larger in one triangle than the other, that means that the angle, so this leg being longer than this leg means that this angle is larger than this angle. So it's just the same thing as the last theorem, only in the last theorem we said if the angle was bigger, that meant the leg or the base was bigger. Yeah, and here it's saying if the leg is bigger, then the angle is bigger. Those two theorems to say some things about these shapes, right? What I want to know about is the relationship to these two sides, WX and XY. I know that these lengths are congruent because that's already marked. Well, this side is congruent to itself, right? because it's its own, the same line.
Because the angles are off.
No, the lengths of the sides are. We're talking about these two sides here.
Yeah, I know.
This angle is bigger than this angle, correct?
Yeah, that's what I'm saying.
So WX is going to be less than XY. So smaller angle, smaller side. Larger angle, larger side. We can go, like I said, the opposite way. We're looking for angle FCD. Wait, FCD, so that's this angle here. That's dealing from this leg, right? And this angle here coming from this leg. So this is FCD and this is BFC. Well, which leg is longer? BC, right? BC is longer, so that means BFC is going to be the larger angle. So, forgot to put the angle symbol in there. The measure of angle FCD is going to be less than. Okay, smaller side, smaller angle. Two triangles that are separate from each other. This side is congruent to this side. This side is congruent to that side. 72? 61?
Segment MQ is less than segment JK.
Yes. Larger angle. No line when you're talking about their measure.
Oh.
Just like, you know how I put the M in front of the angle?
I'll set the custom for you.
Yeah. Without the line, you're talking about how long they are. With the line, you're just talking about that's the segment.
That's retarded. D is retarded.
These sides are congruent. This side is congruent to itself. I want to know about this angle and this angle, so I'm looking at these two sides. So which angle, if I call this angle 1 and this angle 2. So SRT would be angle 1 and VRT, I'm sorry, this should be a V. Change that to a V. And VRT is angle 2. How about we do that? Easier?
So SRT is less than VRT.
Right, yeah. Okay, so VRT is going to be the greater angle because 11 is the greater side length. Wheelers leaving from the same base camp. All right, so we've got base camp. It's tent. Okay, and it's snowy out
Like usual.
because it's, you know, they're snowmobilers, so snow. Okay. Now, group A goes 7.5 miles due west. So we go due west 7.5 miles. And then they make a 35-degree north of west. So they turn sort of northish. And they go 5, that's too fat. 5 miles. And this angle that they turned was 35 degrees. Now group B goes 7.5 miles due east, then makes a 40-degree turn and goes 5 miles. So we have 7.5 miles, 5 miles, but this angle here is 40 degrees. And we want to know, if you come back to the center of base, so this is group A, and this is group B. Who's farther away?
Group C. Group A, I think.
First of all, we need to know these two lengths are the same, right? But we have to find the included angle.
So it's easy, minus 180 from
Yeah.
the number, you got it.
So I take 35 and I subtract it from 180, and that gives me 145. So that makes this angle 145. And then I take 180 and I subtract 40, and that gives me 140. So this angle is 140. So the angle for group A larger than the angle for group B. So since this, so 145 degrees is greater than 140 degrees, that means that group A is further.
Wait, what? Oh, yep, wrong, sorry. I realized what I said.
Okay. So group A would be further from the camp.
Your chart's weird. Just to say.
So here's how we're going to do this. We know that EG is greater than JE, right? And that's going to tell me that, sorry, EG is less than JE. Why did I write greater? EG is less than JE, right? 9 less than 11. So that means that this 6x plus 15 is going to be larger than this 65. So if I subtract 15 from both sides, that gives me that 6x is going to be greater than 50. Divide by 6, x is going to be greater than 8.3, repeating, but I'm just going to do 8.3 because we'll just round it. Okay. That's what x is greater than, but we also have to know that this angle has to be less than 180. It's got a limit, right? It can't go on forever because triangles only have 180 degrees. So we have to give it an upper limit. Does that make sense?
You can only turn around so much.
So we're going to subtract 15 from both sides. And that gives us that 6x is going to be less than 165. And if we divide by 6, x is going to be less than 27.5. So x is going to be greater than 8.3, but less than 27.5. So 68 is larger than 55, so 47 is larger than 5x plus 2. So then I can solve for x from that. So I get 5x is less than 45. Divide by 5, x is less than 9. Since this is already an upper limit, I need to find a lower limit. We can't have a side be less than 0 or even 0, right? It's got to have some length, and length is always positive. So 5x plus 2 has to be greater than 0. Subtract 2 from both sides, then divide by 5, so x is going to be greater than negative 0.4. Sorry, I'm running out of space. So I know that negative 0.4 is the smallest it can be, and 9 is the largest it can be. Nightmare.